Hi, Doc Revis here with Watch Me Work It. Limiting reactant, theoretical yield, consumed excess, and percent yield. Let's work a problem. Suppose that a solution containing 25.0 grams of sodium iodide reacts with 5.0 grams of chlorine gas according to the following single displacement reaction equation, where we have chlorine gas plus sodium iodide, AQ, going to sodium chloride, aqueous, and iodine solid. Here's some questions. How much iodine will be produced from the reaction? In other words, what is the theoretical yield of iodine? Here's another question. How much of the excess reactant is consumed? In other words, how much excess remained or was left over? Here's another question. What is the percent yield of iodine in 15.3 grams of iodine were used? So let's get going. First, to do any of these problems, we must balance the equation. We can do this by inspection. We'll use a 2 here and a 2 here, and the equation is balanced. To work this problem, we must carry out two-dimensional analysis of the masses given, the mass of sodium iodide and the mass of chlorine, to determine which one of these reactants gives the lowest yield of iodine, I2. Okay, so let's do that. First, we're going to start with chlorine, simply because it shows up first in the equation. So if we carry out dimensional analysis to find out how much iodine we get from chlorine, we start with 5.0 grams of chlorine gas, and we would carry out this dimensional analysis times bar here would be grams of Cl2 on the bottom. We'll go to moles of Cl2 on the top, and this is going to for every 1 mole. I'm going to round off these molar masses just for convenience, and this is 71. So 71 plus the number of decimals that are required. So now I carry out this dimensional analysis to moles. That gives me moles of chlorine. And I want to convert the moles of chlorine to moles of I2 because that's what I'm after. And if I look at the balanced equation, I see in front of the I2, there's a 1. And in front of the chlorine, there's also a 1. And I'm going to carry this on one more step over. We have moles of I2 to grams of I2. And if I look up the molar mass of I2, it's half of this value I'm putting here with some decimals. Again, I'm just omitting the decimals for speed here. And that gives us that gives us 17.9 grams of I2. Next, I'll carry out dimensional analysis with the other reactant. That's 25.0 grams sodium iodide. It doesn't matter which one you start with. I just have a habit of starting with the first one in the equation for whatever reason. Here, so we go gram sodium iodide to mole sodium iodide times bar mole sodium iodide. And we're going to do an interconversion here. Mole of I2 times bar mole of I2 per gram of I2. And this is 1 mole per every 254 of I2. It's a diatomic. Here we look at the balanced equation for this interconversion factor. I2 has a 1 in front of it, and sodium iodide has a 2 in front of it. Therefore, stoichiometry is 1 to 2. And the molar mass of sodium iodide, just for convenience, is 150 plus a few decimal points, and we get this. We punch this number through our calculator, and we get 21.2 grams of I2. Since we have a smaller quantity of I2 produced from the chlorine, chlorine is our limiting reactant because of the amount produced here. And sodium iodide is excess. How much of the excess reactant is consumed? So this again is a dimensional analysis. 1 grams of the chlorine gas, which is diatomic. And this is going to be per 1. We have a molar mass, again, rounded to whole numbers here for convenience. And so we'll go moles of chlorine gas. But now we want to see how this relates to the amount of sodium iodide that we should have used. We know sodium iodide is excess because of the limiting reactant work we did. And so now we look at the balance equation, sodium iodide. In front of sodium iodide, I have a 2. In front of chlorine, I have a 1. And I carry this over to see how many grams of sodium iodide I should have used. I've done an inner conversion through the mole to mole ratio. And now I use the molar mass of sodium iodide, which is 150 for convenience gram for every 1 mole. And that's going to give me the grams of sodium iodide that I should have used. Should have been 21.1 gram of sodium iodide. That's how much of the excess I use. So by the way, if you want to know how much was left over in this reaction, you simply take the amount you put in minus the amount that you should have put in. These are grams of sodium iodide, both here. And we subtract this number out, and the amount excess that remains after reaction is done is here. That's how much excess remains at the end of the reaction. So what about the percent yield? Well, percent yield, now that we have the, again, limiting reactant, and we know the limiting yield, so this is our theoretical yield. So since we know that, we know that our percent yield will equal the actual mass or grams divided by the theoretical. And since the percentage is times 100, we punch this number through on a calculator and we get approximately 85% yield. We're just rounding off these numbers for convenience. So there you have it. That's how we get the theoretical yield.